For thousands of years, mankind has wondered, are there planets around other stars? Is there life out there? But we didn't know. We didn't know if there were any planets around the stars.
0 and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Before the launch of Kepler, most of the planets we knew about were really big planets like Jupiter. But Kepler was so sensitive that we started finding smaller and smaller planets.
We discovered planets smaller than had ever been discovered before, and just many of them, indicating that the galaxy's full of planets. Crazy worlds that we didn't predict, things that we hadn't imagined. We find planets orbiting so close to their parent star that the star-facing side has temperatures in excess of that required to melt iron. These planets have an entire hemisphere that's like a liquid ocean, but it's not an ocean of water, it's an ocean of molten rock. We see planets that are orbiting not one, but 2 stars. That is, if you look in the east, you'll see not 1 star rise, but 2.
Almost all the astronomers that I know grew up reading science fiction. That's why a lot of them got into the business of looking for planets in the first place, to find out if any of this, fantastic speculation that inspired us could be true. And now we find out that, yeah, it could be true.
We learned from Kepler that the most common types of planets in the galaxy are unlike the planets in our own solar system. These worlds are intermediate in size between the Earth and Neptune, but we're not exactly sure what they're made out of.
What are the things that we know now that we didn't know then? I mean, things like planets are ubiquitous. Planets are diverse. The stars that we find planets around are diverse. The systems that planets live in vary widely.
It was breathtaking to see all of the planets come rolling in from this exquisite data over the years that we were collecting data with Kepler. In the end, we found dozens of small, potentially rocky worlds orbiting in the Goldilocks zone of their stars, that distance at which you can have liquid water pooling on the surface of the planet, capable of supporting life as we know it.
The science value of the collected data spans almost every field of astronomy and planetary science. It revolutionized not just exoplanets, not just stars, but a large number of the scientific fields of astronomy today.
There was one summer I worked at an observatory, and I would go outside at night and look up at the stars and just be blown away at how vast space was. And it actually felt a little lonely. And when I go out and look at the night sky now, rather than being awestruck by the vastness, I'm awestruck by the possibility.
There aren't that many opportunities in life where you get to participate in a project as important as Kepler is, that answers such a fundamental question that we've been asking ourselves for so long. Now we know when we look up into the night sky that every star we see has on average at least 1 planet, and that many of those planets are similar in size to the Earth and a chance for life as we know it elsewhere.
Searching for life elsewhere is one of the key themes that drive our science portfolio, and at the center of that is Kepler. New missions, like the Transiting Exoplanet Survey satellite TESS and the James Webb Space Telescope, will build on Kepler's success and take our search for life to new heights.
It has been extremely gratifying to see the data come back from the mission and show what we wanted to know, give us the answer. Many stars have planets. A lot of these planets are Earth-sized. That's Kepler's legacy, this new knowledge that we have about planets around other stars.